Hi, I'm Dave Robinson, and welcome to another one of my weekly screencasts where I'll be using R to analyze data I've never seen before. As usual, this data comes from the Tidy Tuesday project, which is a great weekly project run by the R for Data Science online learning community that every week releases a new data set. So let's see what they released this week. Right, we have ramen ratings. Right, I actually don't eat that much ramen. I like some kinds of ramen, but this is gonna be fun. Let me see. So just like last week, we have a rating data set. Last week was a wine rating data set. This is ramen. Okay, so I'm gonna go into my RMD. Load up library tidyverse. I also usually set the theme, the ggplot2 theme, and download the ramen ratings dataset. So usually I start by viewing. Here we go. All right, we have brand, variety, style, country, and stars. Now I wonder if I can get any other data in here, because this has a couple categorical variables and then a numeric variable. So I'm already thinking linear regression to predict the star ratings, but I also wonder what other, if I can get text or something like that to do a text prediction like I did last week in the wine data set. Wonder, it's just to see how big we can make it. Let's see. So this is the rating. I might be doing, this is fun. I might actually be doing a little bit of, screen scraping, some web scraping to grab the reviews. Let's see. So let me just take a look at this for a second. Let's find a bad star rating. This one gets 0 stars. Someone hates Singapore street noodles classic curry. What were they thinking? Rice noodles come out light and fluffy to the point they break too easily. It says disgust, ashamed. Ooh, interesting. All right, so notice that you've got a review number here. Well, here's the review number, but I don't have a link. Okay, I might come back to this in a minute to see if we can grab the reviews themselves. Okay, but in the meantime, let's start by looking at linking the brand, variety, style, country. So all of these are categorical variables that we might use as predictors. Since we have multiple predictors, I'm going to gather them. I'm going to say gather everything besides review number and stars, and call it category value. So this gather from stars. All right. And now I'm going to count the category and the value. I want only the top few from each category. So I'm going to group by category, top n, 16 by n. What am I trying to do here? I'm trying to create a bar plot of all 4 of these categories in the same plot. So I'm going to say as category, this actually should be category, value. So value n geom call facet wrap by category and coord flip. There's one step that I'm missing here. But notice that what this is going to do is give me 4 facets. Actually, a few steps I'm missing here. Scales equals free. It's going to actually say free y here. And I'm also missing the reorder. Ungroup, mutate, value equals FCP reorder, value by n. I didn't want to create 4 separate bar plots. I wanted to see all these at once. What I notice is that the vast majority, first of all, they come from Japan, United States, South Korea, but not a wide selection of countries in general. Similarly, styles, most of them are either in packs, bowls, cups, some tray box, and then kind of other mixed in. And then we have brand. Not quite. Let me see. Try 20. I just want to get more of a sense of this. We can see there's like a long tail of brands and of countries. This means we generally want to lump each of these. Variety, we're not going to get anything out of. We can tell because if I do count variety, Ramen ratings, count variety. Yeah, a few have beef or chicken or miso ramen, but like, not, yeah, not that many. It's such a wide. This seems like it's a subset of the brand. Yeah. So okay. So it's not. We're not going to get that much of the variety unless we tokenize it. Because notice some have the word curry or such. We might be doing that. Style. So what are we finding? We're finding that style probably needs to be lumped. So say style is FCT lump, and we can see there's kind of 5 and then everything else. Style by 5. Yeah. I also need a box is not even probably just style 4, and I need replace NA style equals other. So here, yeah, we have pack, bowl, cup, tray, other. Box got lumped into other. Okay, so that's a lump. We know that country should also be lumped. Looks like it's never missing. That's useful, but I can say country, FCT lump, country, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. Here we go. Now, other doesn't get ordered perfectly because it's in multiple of these. I've got a trick for that I might show in a minute. But for now, I'm just keeping an eye on all of these at the same time. Brand. Oh, I don't know where to cut off brand, but I'm going to say FCT lump. Brand 10. So it's just however you feel. Notice that other is definitely the most common brand. There's kind of this wide variety. Maybe I'm going to do a bit more. It's not going to. It's other's still going to be the most common, but But if it's important, if like brand is like an important distinguishing feature, then yeah, kind of want to separate these. Okay, so I didn't even look at how many ratings there are. There are 3,000, so fewer than the wine data set too. I don't mean to keep comparing it. All right, I'm gonna start by saying here's our ramen ratings clean. So I'm going to call it processed. It's not that the data was dirty. It's that we did some aggregation on it. And this gives a feel for how that splits up. I'm actually going to show you how to keep other from being at a different level in each of these. That's because when it orders the factor, it's not able to have given different orders for each facet. I have a tool for that. It's in the drlib package, the personal package available on GitHub. I haven't seen anyone else come up with a tool for this, so I still use my own. It's called reorder within value by category. And I actually also need to add scale x reordered. There it is. So by these two steps, reorder within and scale x reordered present in the drlib package, we can order this to show the most common categorical variables. So I'm going to call this title is categorical variables after processing. I'm going to call it categorical predictors and say x is predictor, y is count. So notice, yeah, you can kind of get a sense of lots of other countries, even more other brands. So brand, yeah, it's going to be generally kind of hard to distinguish, and then style here, style and variety. All right, so I'm going to, I'm going to try a linear model to predict stars. It's similar to what we've done in previous sessions. What we're going to say is stars. On ratings processed, ramen ratings processed, stars explained by brand, country, and style. Use a broom package. It's nice to tidy this up. All right, we're actually going to do to visualize this. Probably a good idea to do a coefficient plot. So I'm actually going to add confidence intervals to this. Conf int equals true. And I'm going to plot it where we say estimate term geom point geom error bar h. I want horizontal error bars. And what is it? It'll be x min equals conf low, x max equals conf high. And I neglected to do any ordering. Term equals FC2 reorder term by estimate. I also never want the, almost never want the intercept term in a coefficient plot. That's pretty cool. So this shows what's the effect of a, let's see, estimated effect on, on ramen rating. Subtitle, common brands, countries, oops, this is title, coefficients that predict ramen ratings. I don't know why I did capital R here. Common brands, countries, and styles. Did I miss common brands, countries, and styles? Yeah, all right. We're lumped into other. Less common. All right. I'm also, now that I realize it, I probably want to use other as the, were used as the reference level. So one thing we didn't discuss is that in this model, what are all the terms relative to? What is this brand relative to? Because other is one of the most common categories, I actually want to set, for brand and, let me see. So what I do is, let's do this. I'm going to do it in the processing. For brand and for, let's actually show this graph again. What is the reference level? This has to be decided each time you do a linear model. For brand, it'll be FCT relevel brand by other. No question. Other's the most common, so we want to compare all of these to like the everything else. Country, yeah, let's do other. It's pretty common, so there's enough data. And, but for style, we don't want to use, it doesn't really make sense to use other. Style, let's use pack, because it's the most common. So one thing we'll find is like, yeah, cup is actually negative compared to pack. Do we have positives brand? Yeah, there it is. All right. One thing I can do here is if you realize, I realize now I want to separate each of these categorical predictors. So I don't like having a Y, anything there. Yeah. So what I realize is I actually need to do a little bit of extraction on the tidy data. So I'm going to say, all right. I'm going to say extract brand, country. Trying to figure out how do I split this. All right, yeah. The way to split is like I want something that is not uppercase and then uppercase everything else. It looks like that actually is the only type of predictor I have here. Extract is a great tidyr verb where I say give it a regular expression where I say some number of lowercase, some number of uppercase, and then an uppercase, and then anything. So like we start, we have some lowercase, then we have some uppercase, and I'm doing that on the term column, and I want to extract it into two columns. One called category, the other called term. And so notice, just by doing, and then say, yeah, I broke it up into parentheses being the caption groups, brand and term. Yeah, that worked pretty well. And that means that I can now say color equals category. I like that, because now I can say, what's the ordering of the style? Oh, actually, I like it even more if I faceted by it. Facet by category. I only want them in one column, I think. I missed something. Oops. Forgot to do scales. Free. Oh, nope. It's going to be free Y in here, even though it's on the x-axis because of the coord flip. Here we go. That's pretty good. I can leave in the colors. Not all that necessary, but I can sort of leave them in anyway. But then say theme legend position equals none. Brand, country, style. Often on a graph like this, I'll throw in a geom v-line LTY equals 2, x-intercept equals 0. 0 has a very important meaning here. It's like anything that overlaps 0 doesn't have a statistically significant effect. So Ace Cook is a bad brand relative to the general market. Koali, were lumped together. I'm going to say brands and countries. There we go. Now I've created a coefficient plot. Like I said, if you watch this each week, last week I did a wine analysis where we had a very similar coefficient plot. That's one of the reasons I'm rushing through this a little bit, is I wanted to show like, I want to show, because we've seen this before. Generally, it shows like Indonesia, Malaysia, Singapore have the best ramen, followed by Japan, Taiwan, UK, Vietnam, Thailand, kind of not really distinguishable from the quote other category. It's like most other countries in the world. US, just barely edge of statistics, maybe not. Given how many hypotheses we're testing, not particularly significant. I wouldn't call it that. Okay, and cups are less good. Other might be better. It's hard to say because other, remember, was pretty rare on this style. So like these were two graphs that we can kind of gives a feel for how we would do a prediction. I didn't do anything with the counts. That is with these really sparse ones, the style. I'll tell you something, if I were just doing this on a regular Tidy Tuesday, what I would do would be to unnest. What I would do would be, I'll do it super fast, but not all of it. Just so I would take ramen ratings processed, unnest tokens for the variety, count the word. So it's actually, you see like some words like noodle, instant, etc. I could also group by the word, summarize the mean of stars, and say what is the average rating for things that have those words, and then also include an N. Keep writing starts instead of stars. Should probably filter, not isn't a stars before there. Yeah, so we can see like in general ones that have chicken, lower rated, ones that have spicy, ones that especially have, well, I guess the word ramen has a higher average rating. Now we haven't distinguished this from these other factors. Like I said, last week we did, so in a previous session we did wine ratings and we did lasso regression. And that's a great method for seeing for all these words which have a positive effect, which have a negative effect. Because I just did that last week, even if you didn't see the screencast, I just did it, so I want to try something new. I'm not going to go deeper into that, but know that that's how I would work with that column. I wouldn't use it, I wouldn't lump it because it's too sparse. We saw there's too many different counts, but I absolutely can say what words have, I can absolutely what words when they appear. Since some of these words are pretty common across noodles, have a positive or negative influence. All right. Instead, what I'm going to try is web scraping. Oh, oops, I saved it as untitled. All right. I'm going to rename that. All right, so I'm going to do something else. I think that in one previous screencast, I've shown web scraping with the rvest package, but it's been a while, so I'm excited to try this out again. What we're going to do is we're going to try getting the text of these reviews to augment our data a little bit. So what we're going to do is go to our ramen data set. This comes from this page, and it looks like this is what we were working with, review number and so on. Yes, and this was probably scraped. I'm actually curious, do we have the text for screen scraping? No, we don't. Not provided in GitHub. So what I'm going to do is actually pull this data myself and get the reviews. So we're going to use a tool, really amazing tool, two amazing tools really. One is called rvest. One is Selector Gadget. So Selector Gadget is, you can install it with Chrome, probably with other applications as well. What it's going to say is I'm going to select a section of this graph, of this page, this web page, pardon me. And it's going to give me, select it. It's supposed to highlight in green, but that's okay. It's going to give me this this selector, CSS selector, which is really a potent way to say, here, I'm going to start with read HTML. So I'm going to call it ramen list. They have a tool for we read the HTML, download it, and parse it. So if I looked at it, it would be this XML document. But rvest provides these tools for pulling nodes out of it. In this case, I want to pull the node HTML node number sign my table, pound my table. So here we go. Oh, yeah. So what it did is it actually pulled out that one node from this, and I can then actually feed that to, I think it's called HTML table. Is that going to work? Oh, and let's make it a table df. Surprised me that HTML table doesn't return a table diff. Here we are. So we have is ramen reviews. So notice that's how we could have scraped this data ourselves with just a couple lines of code. Also a little like we do some janitor clean names. We'd fix my own spelling. Excuse me. Ooh, that's so cool. It does. I didn't know that janitor replaces this with review number. We do a select. We remove that last column. I bet you this is how how original data was probably created. That's pretty cool. It's not what I'm. But we didn't need to do that. We can actually just have it show up like this. That's not what we're doing today. What we're doing is take a look at our ramen reviews. I want to get the links, each of these links, and know what it links to, so that I can start downloading their text. I don't know how many hours. We don't have much. We don't have to sit here and let it run. So I don't know if I'm gonna download all the reviews or just a few. Gonna figure that out. But let's get these review links. So I click this button once to say I want this column, this one to say I don't want these other links. I get 3,180. That sounds about the number of links that pop up in here. Yep. That looks like that worked. So it says, oh yeah, I want the links in the table. So I'm going to say read HTML, HTML nodes, not node, my table A. So this would say, that I want just the links in the table. I'm going to call this review links. Worked pretty well. And then I want HTML attribute of the review links, href. And I'm going to say review number is as integer of HTML text of these review links. So I create a little table. Here we go. Now we have the review links. Wonder what got an NA there. Eval tidy. Oh. Filter is NA review number. Bond chicken salsa. What was that like before? I'm going to add this as a column. Little trick, I just want to say like... Oh, shoot. I called the same thing twice. My bad. So one thing I wanted to check is what did it used to say? Filter review is NA review number. Oh, we had a little... they had a bug there. I'm not going to... I know what I'm going to do. Instead of as integer, I'm going to do readr as parse number on this, which actually will get rid of the parts that aren't like clean. Like if there's a little extra text, it'll realize, nah, I don't want to use that. Don't try and parse that. Now we have all the review links. All right, just want to make sure I got that. Okay, so I'm going to grab one of these. Yum Yum Mu Deng. I'm going to grab this one's page. I'm also going to visit it because we're going to now scrape one review. It's a longer name. Yum Yum Tem Tem Tom something. All right, so I'm going to grab this. Looks pretty good. All right, what I want to do is grab the text out of the review. I don't think I have anything here like a reviewer or something that I'd want to grab. I think it's all the same, probably all the same person. All right, so what I'm going to do is say, I want, selector gadget. I want this paragraph. I do not want paragraphs that are just like a picture. But I do want this one. I'll leave the picture and I don't want the subscribe to blog via email. I want it to be in this main section. And I don't want any of these. Notice that every time I do this, it's changing. It wants, entry content. Paragraphs in entry content is how you read that CSS selector. And that's really handy. It's a nice way of parsing out the section I want. Okay, so I'm going to go ahead and grab this and say, I want to take this page, HTML nodes, grab all the nodes that fit this pattern. Looks pretty good. HTML text. Here we go. And now we see it, and we can see out of this many stars. Okay, what I notice about this, we're probably going to run to it more often, is that there's like little text, there's some like chatting, and then maybe some captions. Then the interesting part, the part that actually has the this is good, this is nice, or is this spicy? Like the actual review looks like it comes in a line with stars. We're probably going to pull just that one out. But in the meantime, that was pretty cool. Notice I got I could throw in a quick string subset. Say you must have at least one character. It's an easy so string subset says it must match this regular expression. Could have said must have the word stars, but yeah. So I can actually. So I would say get review text function URL, and what I get is, here we go, read HTML, grab each of these, and this is a script for getting the review text from given any URL. We got a little function for it. So now I can say mutate text equals map link get review text. That's pretty cool. We've got a character column now. If I like, I can unnest it. And now we have the review number and the text, and the link, and the text all in one place. I'm going to do it, I'm going to add a couple things. I'm going to message the URL. Yeah, okay. I'm going to create a 25. I'm going to say review text and map it to get review text. And yeah, I'll leave the unnest. Why not? I'll also leave the link. Never hurts to have that. Why'd I add a message? Because I like to see progress happen. Otherwise, it might be a little bit dull. and you can always worry that it's getting frozen or something like that. Speaking of getting frozen, something that I often do with this is it works really well with tasks like this. Actually, I'm going to get to it in a second. First, take a look at our output. Here we go. Now we have our text. Anytime we have a text column, I've already done a little of this. We always find ourselves unnesting it. I just love to find out what are the common words. Unnest tokens, text, word text, count words, sort equals true. Usually I like to throw in an anti-join on stop words. You can find out more about this in the book by me and Julia Silge, Text Mining in R. One thing we find is that there's a couple words appearing exactly 125 times. It looks like all of them have the word pork and yum 5 times. Yeah, I could definitely imagine. I could imagine that. Oh no! Did you catch this? I didn't catch this. Oops! I was reading the same URL every single time. Imagine some of you were following along at home and just shouting at me. Is that here we had read URL and we just had the string fixed there. That wasn't very handy. Oops. So I was like, these numbers are too clean. I know there's some repeated text, but why would pork and yum be repeated? I was like, no. Oops. Okay, so this ought to fix it. We get 25 review text. And now we see some of the common ones are like click to enlarge, things from captions. Those are, yeah, a little bit less interesting. And if we take a look at this, I bet you we're going to see the line like, watch me cook an instant recipe noodle time. Do we see that multiple times? Yes, we see that here and here and here, maybe in every review. And we notice that there's kind of some like, what do you call boilerplate that pops up on every page. That's not interesting. In fact, I think the only one where I really want, if I really want to analyze something about the reviews themselves, I mentioned this before, it's always in that last paragraph that has the word stars. So if I took review text, it's one row observation per line, and I can filter string detect text stars and say, every one of them has one of these. Finished, click to enlarge. Honestly, I could have filtered for finished too. And yeah, I still want to remove, and I probably still want to do string remove text. Oops, I need to do mutate text equals string remove from the text the words finished and then a period and a space. Oops. Finished, this means not greedy, so some number of letters. I could have done click to enlarge, I didn't want to add that. So there we go. We got and now we move it to like, this was nice, or often they say it says what the reviewer added, spring onion, etc. And here I can say review paragraphs. So now I can say of these review paragraphs, what are the common words? And I'm probably also going to filter string detect at least one alphabetic character in our word, A to Z. But yeah, barcodes, stars, and we saw added pop up a lot. But mostly, yeah, we have these descriptive terms: broth, noodles, flavor, soft, onion, bean. Some of them probably are positive, some are negative. All right, here's what I'm going to do. I'm going to increase it to 100, then we'll do a little more analysis. This is actually a common approach that I take, is I keep increasing the number. In the meantime, I want to show you something really cool. There's something called there's the per package has these functions like possibly. What possibly does is say this function, if you run something that's going to run like a somewhat slow function on many thousands of steps, the worst case scenario is it fails on one of them, like because let's say one of these didn't have any of these, any paragraphs in it for whatever reason, just one, and yet it breaks and suddenly all of your work you've done so far is gone. So what you do is you work safely. So let's see, R for data science per safely. I want to remind myself where the Yeah, there's this great section in R for Data Science that shows the function dealing with failure. That's the one. I'm actually gonna have a link to it. Here it is. Dealing with failure. I'm adding this to text. See here for more. I'm adding this for people that are in the future reading it. Possibly and other dealing with failure functions. Aha! What did I tell you? I got a 404, but I haven't set it up yet. So this is super handy if you haven't seen it before. What it says is I want possibly, and I'm going to have a default null. I don't even remember what happens with unnested and has a null. So I'm going to, yeah, so one of these links didn't work. It looks like maybe this link. Yep. It looks like, well, at least one of them was missing. So it's important we saw that. But here, we're going to run it again. And means that we'll keep busy somehow. What it's saying is possibly with a default of null. So when there's an error, I probably should have said quietly equals false. I'm remembering now. There it is. Possibly always succeeds, and you can give it a default value to return. So here it's going to give back a null when it which is equivalent to an empty vector, which is kind of good because this is giving me a character vector. Here it's giving me an empty vector. If it runs into any kind of error. I've added a quietly equals false so that it'll show the error here. So if I'm just watching it, I'll see the error go by. There's nothing we could have done about it. It's just a link to a review that maybe was removed. But yeah, here this is how I would parse it. Yeah, so this is what I do here when I'm getting impatient. Is I'll grab this. You're watching this on video. You're welcome to skip forward, wait until this is done. But what I could do is say, how many lines I got? Ooh, we're almost done. All right, and now I'm going to show again review text and review text unnest. So that's good. I'm glad I didn't run this because what happened is I have to say filter not map logical text is null. So notice there is a null one here. So say here is review number, etc., etc., etc. I could have done character 0, couldn't I have? That's what I should have done. I'd say character 0 for next time. Now I know. But for now I could say not this and unnest, and that would be my review text. I can remove this now. I can say, it's nice to keep, if you have a step that takes a long time, it's nice to keep it in as raw form as you can. Because then I can do whatever process I want. If I find I later want to look at the first line of each review, I can do that myself. I can say, grab this section of the text. For now, here's my review paragraphs. There they are. So it turns out we had 97 cases of finding stars in each. Seems like some of them didn't have that line where they gave a star rating. I wonder if I did a finished. There we go. So some of them don't have stars. So this thing you'll find when you do screen scrape is it's never web scrape. It's never exactly not string detect text stars. Pull text, not scored, no score. Okay, so we do have ones that aren't scored. All right, I can leave those in anyway. Here's my review paragraph. So we have 99 scores. What time is it? Deciding whether I want to fit a model. Like I said, I've done, and whether I want to download more data first. It can be really addictive to download more data. Like you can just do it all day instead of actually doing coding. I'm going to do it. hard to do anything with fewer reviews. I'm gonna run this. Oh, it's not quietly equals false. Is it quiet? Remind myself. Quiet equals false. So I'm gonna run this. And I'm just gonna stare at my screen or maybe my phone, and you can fast forward. I will download 250 reviews. Good luck. If you find yourself letting this run in the background and you hear me talk, one thing I was thinking is I should have puzzles ready or something, like something quick I can do, like a trick of the day that I can do while I'm waiting for this code to run. It's not a common situation I found myself in these screencasts, but it would have been useful in this case. Oh, look at that. We caught an error. All right. Hooray, I hope you're back. All right, so we have a review text now. I can try running this line again. Good. All right, and we have 247 of those 250. We have a review paragraph. So now we can work with these paragraphs. We could do other things with them, but now I can work with these paragraphs. We find that here that almost all of them use the word stars, as well as barcode, and we saw they start with the word added, and then we work from the, our way down from there. Now if I, here we go, I'm going to leave this, I'm going to call this review paragraphs tokenized. I'm also going to, what am I going to do? I'm going to inner join it with my original ramen data set, ramen reviews by review number. The reviews in the original one were character? Probably because they used a similar approach here. All right, I'm going to fix that. I'm going to say review, yeah, I'm going to say mutate review number equals parse number review number. On ramen ratings? I'm doing something wrong. Oh, oops. Okay, sorry about that. The reviews, here's where we have a, oh, no. Wait. Wait. It wasn't ramen reviews, it was ramen ratings. Oops, sorry folks. Here it is, ramen ratings. Could you use ramen ratings process? Does it make a big difference? Yeah, so we have as like brand, variety, etc. But importantly, we have stars. So we can take this data and say group by word, summarize, number equals n, reviews is n distinct, because someone could appear multiple times in review number, and then I'll say average rating equals mean stars. Here we go. So I'm deciding whether I want to use a lasso regression on this like I did last week. I'm not going to, just because like I said, I've done a bunch of lasso recently. I'm just going to use the average rating, but we're going to try a different type of plot. Here I'm going to arrange descending by how many reviews something appears in. I forgot to say, filter not is an A, stars. Here we go. So I can say review. So I'll call this review words, and this would aggregate my words by how many times they appear. Stars, bar and code, not very interesting, and so on. But so here's what I'm going to do instead is I'm going to look at co-occurrences. I didn't do this in the wine data set, so I'm trying something else with this data, where I'm going to say, let's look at what are common sets of words that appear together so we can get a visualization of a network. And for that I'll use the YDR package. And I'll say pairwise core word by review number, sort equals true. I think I need to start with distinct review number and word. I don't know what will happen if I don't do that. Yes. So for example, some of these always appear together, bar and code, code and bar. That actually makes it not that interesting, especially because those actually end up being too common. Fork and lengths always appear together, and let me see something. If I left join this, no, I'm sorry. If I inner join this with review words by, I'm going to call this word cores. Oh, it just hit me. We're including ones that are too rare. So what I'm going to do, that are if they occur, if each of a pair of words only appears once, the correlation is perfect. Also, it appears too often. So I'm going to say review words filtered is review words, but only filter where reviews is less than 200. I don't want noodles added, barcode, or stars. And reviews is greater than 10. Start with that. And now I'm going to say take that, review words filter. Oh. Take this, Semi-join it on review words filtered, so we're only using common words. Distinct and pairwise. Here we go. I like that more. All right, so then I could say word cores. So here are my word correlations. Mung and sprouts, mung and bean, or bean mung. I don't know my way around these vegetables and spices and such. So what I'm going to say is take our word cores, take the 200 highest correlations, and we're going to use the gggraph package. Also igraph. We're going to create a correlation. You can find out a lot more about this in tidytextmining.com. In tidytext, relationships between words, n-grams, and correlations, we can build these kinds of graphs of word. Oh, those are bigrams. Here it is. Of word correlations, this word network, and we're going to build a graph that looks a lot like that. So I'm actually going to link to it just to make sure we have this. We've used it at least a few times more on correlation graphs with words. Here we go. I'm going to say take your top 200, graph to data frame. I need to run graph from data frame. And gggraph. Where gggraph is a great tool built by Thomas Peterson, and it's based on the grammar of graphics, but approaching network plots. Geom edge link, geom node point. Here's our graph so far. I almost always set seed. It doesn't look like much yet, does it? Give it a minute. And I'm going to add geom text AES label equals name, vjust1, hjust1. I'm actually going to do it a little differently. I'm going to go with hell equals true. Geom node text. I'm really, here it is. I'm a little out of practice with this. So here I show like, oh, nicely hydrated. Thinner style, mouthfeel, seafood, shrimp, etc. So on. That's pretty cool. But I can actually get a little bit cooler. I can say I want to include all the filtered words as vertices. How many words are in here? I'm going to try this once. It's going to have a lot of extra points. I'm not so sure I'm going to love that. Yeah, I don't love this. What I'm going to do is say, here it is. I always find myself doing this. I say filtered cores, and I don't have a faster approach yet. I need to say take your filtered cores, and then your nodes are my review words filtered, but filter where word is either, notice filtered correlation. I can say it's either item 1 or word in filtered cores item 2. Vertices equals nodes. So now I've created a subset of these vertices. Why did I do that? Because now it lets me use aesthetics at the node level. Say that size is the number of reviews it's in. So now I can have the bigger points, the points that are more common end up show up bigger. Now I've got some overlapping words. I've got some words that are a little harder to read and such. I'll be working with that in a second. But here's a great thing. I can also do a theme void is my most often common operation. Yeah, and I would say it's a little bit better of a scatter plot. I love how it shows like pepper matches Szechuan, matches scallion, matches chewiness, savory, broad. It's quite an interesting shape of the network. Then we have this batch of things, Cosmos sprouts. It looks like it's a group of ingredients. Actually makes me think that 200 connections is not quite the right number. Yeah, I kind of like this graph. It shows one really heavy cluster and kind of spreads out from there. Now, why show things as a graph? It's a little bit interesting, but what can I learn from it? Well, I can learn from it if I use another aesthetic that I set up earlier with this in mind. Average rating is like, for this word, how many what's the average rating of a review that has this word? It's much simpler than a linear model because technically it could be confounded across many of them, but it's pretty good for a graph like this because I can say size and color color equals average rating. Gonna need to change this axis a little bit, but it's going to show. Here we go. Is that EAN? So some areas are a little bit brighter, some are darker, but I'm gonna set up a new scale color gradient 2, where I say low is red, high is blue, sure, blue, and midpoint is, I don't know, we saw the midpoint earlier was like 3.6 in terms of a median. Now I need a lower midpoint. Everything is blue right now. I meant a higher midpoint. Here we go. So notice now where it's saying like, oh, there's some, now we can look for areas of blue meaning higher ratings, or red meaning lower ratings. So excellent. Fried mouthfeel, quality and quantity both are positive. Looks like impressed, hearty are positive. But this whole area of salty salt, life, baked, cheddar, chicken, pepper tend to appear in lower reviews. All right is quite a negative review. So that's definitely some things I can learn from this. Notice it's a little bit hard to like see all these points. I have a trick I use. I can't remember if I've ever used it in a screencast. It's a silly trick. But what I do is I create under the other points. What I actually do is say, let's create a separate point under the first one that is slightly bigger. And that actually makes it look like each of these are outlined. I don't have a better way of doing that. I've done it for a lot of my graphs and just noticed that it really kind of makes it easier to see these points. Let me see. I need to add a couple labels. Say labels color equals average rating. Size equals number of reviews. Network, and I say title is network of used in ramen reviews. Subtitle based on 250 ramen reviews. Words used together and their star ratings. It's great. I ended it just in time, so I ran this whole script again, including the set seed, which is nice. Good. So I spent about 20 minutes ago, I spent 5 minutes letting that scrape run. It's important to get as much data as you can while still fitting within your time constraints. I'm happy with how I did on that because I spent 5 minutes, got 250 reviews. Could have gotten a little more, but now I get to see these discoveries. I see that I mentioned fried and mouthfeel, hearty and impressed. These blue areas, nice, chew. These are kind of positive. There's negative areas like salty salt, life, chicken baked. All right is the most negative. This whole area of Cosmo Mung, sprouts, onion. I think it's some particular kind of ramen that might be really common. And it's middle of the road, it looks like. Around a 4 rating, it suggests on average. It's instant. It tends to be associated with negative reviews, maybe some kind of farther on the red scale. Okay, so that was our network plot. Let's review for a moment what we did. We did some exploration of the original ramen data. In particular, we had only 4 categories, so I showed them in facets so we could understand what's used as predictors. We didn't follow up more on this, but we used these predictors to create a coefficient plot based on brand, country, and style. And I mentioned that if I were going to use the other one, what was it called? Variety, I would have tokenized it. But then we moved to the web scraping side, where we learned how to use the selector gadget tool to go into each of these and actually pick a CSS selector that would extract the text from each. So I extracted all the table, basically recreated some of the data, and then I created a function to extract the text. And finally, once I had all this text, I had stars. I decided I was going to make one of my favorite kinds of plots for working with text and stars, which was one of these network plots with using color as an average rating. If I'd had about 20 more minutes, I would have let it run not just on the 250 reviews, but on a larger selection. I guess maybe it would have taken an hour to run for all of them. Definitely would have been fun. Okay, that concludes the ramen and tidy text analysis, and with tidy text and rvest analysis. I hope you had a great time. I had so much fun. I'll see you next week.